You might remember I gave a lightning talk on this very same topic at the ELS in Amsterdam last year. I threatened to write a paper. Here we are. Comments on the paper include, oh, it's a perfect little here's what we've done paper, and there are no great insights into DSL design, and some of the technical details are low level and boring. Let's dig in. So Ravenpack converts unstructured data, aka raw text, to structured data. This is mainly for the financial industry, and as part of that, it's very relevant to know when something has happened. Cue the period detection system. So we're interested in time and date information. Here we have a raw example, the 19th week of 2024, which you might want to then extract as a time interval covering that week, obviously. We do this through periods, and a period has basically three parts. A type, which is a sort of categorization, so we can build periods on top of other periods and such. A pattern, which we see here, numeric ordinal, literal week of period absolute year. Period absolute year is also a period, so that's the case of this sort of building on top of each other. And an extractor. Here we have an example of an extractor. I've just kept the pattern at the top here for easy reference. You see that we extract some value from the numeric ordinal, we extract the period from the period absolute year, and then on top of that one, we add something to the start of it regarding the specific week we're interested in, and we make sure that it ends a week later. Right, and all of this is, of course, proprietary because it builds on top of existing Ravenpack systems, etc., and wouldn't really nicely separate. So that's sort of something we have had for years. And 2 years ago, when we sort of started this whole let's make a DSL thing, the state of the workflow of this was non-developer team members, let's call them editors, were through looking at documents and such, find missing or poor periods. They would file requests to have a developer add or update with the desired behavior. This would sort of lie around for unknown amounts of time, which led to a slow feedback cycle. It meant developer availability worked as a bottleneck for this. It separated the domain reasoning regarding how should this particular text extraction behave from the implementers, and there was a sort of ad hoc quality assurance. It worked, though, as evidenced by the existing corpus of 1.2 thousand periods. I should learn to write prettier. Right. So at last year's ELS, someone asked, how do you convince management to do this sort of DSL project, which I blanked at the time. And the answer is I didn't. What we had done was automate or put under editorial control other parts of the system, which were simpler. And having that taste of power, the management of the editorial team approached me and asked, hey, can we do something similar for the periods? Then we did an analysis, failed to find simple solutions because of the arbitrariness of the period extractors, and went ahead with the DSL one. So this has sort of been intermittent work spread across the last 2 years, often interrupted by other priorities for months at a time. Started in spring 2022 with the analysis of the existing corpus and concurrent drafting of a spec. At that time, I was the secondary maintainer of this system. And we first did a sort of similarity pass to see, hey, what sort of stuff do we need to cover almost all here? And then we did a difference pass to see, is there more stuff we ought to have which wasn't caught by looking at the nice cases? There was definitely functionality. We could have added to handle those, but many of those were sort of not the best extractors to start with, and the complexity gain didn't seem like it would be worth it. After that, we did a subsequent lo-fi design thinking inspired try it on a test user, implemented the thing in the summer, and then it was just UI development and tooling and such dragging on and on. Some of which we'll get to later and some of which we will skip. Obviously, details are in the paper. I do think the lo-fi design, the lo-fi DSL prototyping part is interesting though. So we had the spec we'd written and obviously wanted to test it out for feasibility reasons because the end users of this DSL are not professional programmers. They're people with no previous programming experience. So we had a test user, we had the spec, I gave him the spec, and I told him, hey, write some extractors. No implementation available. Send them to me on chat. I'll simulate the compiler response, etc. of the system. Extremely lo-fi, pretends. This worked fine in terms of verifying that the spec made sense, test user was able to write it, etc. However, what I had hoped for was a sort of rapid iteration approach where he would come up with critiques, suggestions, and we would improve the spec. Unfortunately, due to a lack of confidence perhaps, or just the impression that, oh, I've gotten this spec, it's from an expert, whatever, this didn't take place. So, worked for feasibility verification, didn't work for the rapid iteration stuff. What would I do differently? I would probably try, here's a dozen different specs, have fun, because that would give a sort of broader sense of the design space, hopefully point out that, oh, there are options here, etc. So, we named the thing Peril for period extraction language. The goal was to have a sort of simple and minimal thing that covered almost all the functionality. We knew it wouldn't cover everything. That was fine. And because users didn't have previous experience, that meant we could stick with a simple syntax as expressions, obviously. So the thing looks very Lisp-like. The big difference in semantics comes from the fact that all of the vocabulary is locked down. So we have a set of roughly 40 operators. That's all that's available to the users. They can't define functions on their own. That sort of changes the approach to the entire thing. There's also a set of simplifications to minimize the sort of need to learn cultural aspects or historic aspects of the Lisp language, things outside of the necessary domain, etc. So we don't really have keywords, we just treat everything as magic symbols. We have a square bracket list construction thing, a sort of minor rewrites of the symbols like true and false rather than t and nil. So 6-style language analysis. What are the primitives of the language? We get these attributes from the existing parts of the system, like we saw in the patterns earlier. Numeric, ordinal, literal, weak, all of that. Then we have numbers, words, aka symbols, strings, lists, and all of these built-in operations. From the end-user perspective, all of the operations are built in. In terms of combining this, various built-in operations construe new period specs from existing ones or parts of ones that might be defined on the go. And the abstraction is then the fact that once you have a period, it becomes part of the stuff we detect under that particular category of them, and other periods will then automatically build on top. So the periods that get added become available for use in other ones automatically as a black box abstraction. Couple implementation details. We validated the legality of each atom based on the stuff in the language to make sure that stuff outside doesn't get referenced, etc., for sanity reasons, and to give friendlier messages in case of errors. All of the inbuilt operations have the type information associated with it in a sort of very simple static manner. You see here that add returns a spec, takes a spec, and then we have this subspec thing for the start and anchor and so forth. All the implementation details are available in the paper. Tooling. So this was something very fun. As part of making this system come under editorial control, we had to move stuff from living in source files to living in a database. All of it was sort of macro-based, so wrote a macro to just stuff things into the database. Largely done. However, most of the periods had comments in the source file regarding what sort of document it had been made against, what sort of text, etc. And preserving that sort of context would be useful for the editors, so they would be able to see, this is why this thing exists, makes sense, doesn't make sense. So to do that, I wrote a script that turned all comments into this sort of little informative list structure, rewrote a macro to go through all of that, punch things together, classify arbitrary documents and make sure that the thing still could be detected, and search for new context to use as the canonical context in case it didn't. So comments as data, fun stuff. Also, because of existing UI restraints in terms of what all the other UIs that editors use, the UI for the period detection system is in the browser. Just having a plain text area is, workable, but not too convenient. So added a code mirror editor, because Zach Bean had heard good things about code mirror. That went fairly smooth. I think it took like 1.5 weeks or something. Good documentation can be implemented in a sort of largely declarative manner. I had to write a little lesser grammar, which is the stuff for code mirror library, for the language, which was fun. Had to break the declarative interface on 2 occasions. One of them being I wanted to very aggressively auto-indent everything on every single edit of the extractor. So that required iteration. And the other was I just couldn't get it to nicely separate numbers and symbols in the lesser grammar because of the particular parsing algorithm. And we see here that the editor offers auto completion, description of stuff, syntax highlighting, except it doesn't happen to be there. Here's an example extractor. This is sort of a spilled one from the basics because there's nothing in this particular case to build on top of. So we see that we construe here a spec for the past several literal weeks, going back 3 weeks from the current date. Why 3 weeks? Editor decision, I don't know. Simplest possible extractors. Here we have some text surrounding an existing period. The text doesn't really add anything except journalists find 1,000 manners to write the same thing. Extract the existing stuff. Good, pass it up. One of the means of combination is literally called combine. Sounds very tempting to use. Unfortunately, it's also one that's easy to trip up on, but in this case, worked fine. And here we see a more complex example where we have a period absolute day and we want to add something to the start of it, and we also want to overwrite the end to have a 3-hour period going from the start of it. So, means of combinations compose, obviously. And that's sort of one of the things that makes it fairly easy to reason in this language. The fact that all of the operations, or most of them, work on this superior spec layer. So stratified design, almost algebraic, whatever. Summary. Apparently I'm the person who gets us back on time. More details in the paper. The lockdown the lockdown on available vocabulary is also a qualitative change because you don't really go around thinking about, hey, what operations do I need, subsystems, all of that. You start just dealing with an extractor at a time. in trying to make the thing simple, we sort of ended up with accidentally declarative design that matches the observations in concepts, techniques, and models of computer programming, where Van Roy, I think, makes the case that declarative languages are the simplest in terms of not use necessarily, but the language constructs at play. And the test use is written almost 400 pages while the system was still in development. And of course, as a nice surprise, all of these extractor examples are indeed written by the test user. That's it. Thank you.
Okay, thank you very much for the conciseness. Any questions?
Yes, I guess I kind of have a two-part. Like, was there more than one non-traditional developer writing these DSL extractors?
Not so far.
Not so far. Was there any pushback or friction with S expressions?
No. People really get stuck on what they sort of. I think a lot of developers get stuck on sort of, hey, this is my first language, this is what I'm used to, and then any sort of change from that subsequently leads to friction. No previous experience, what's there to have friction against?
Any other questions? Okay.
Do you have any data about the accuracy of in the usage of this system?
No. We have sort of, just rolled this out, and we have improved various quality assurance mechanisms and validation processes as part of that, but we don't have that data yet, no.
Maybe you said this and I missed it, but how long did it take you to write this?
Two years of calendar time, roughly half of that was spent on this, and half of it was spent on, oh, we have this incident, or oh, we have this other priority. So, back and forth, context switches.
Any other questions? I have one that is almost a joke. That's
Go ahead.
One of Gary Marcus's latest posts was about. Actually, I don't remember where it was but it was about Gary Marcus, about his son being 1 year old in 2014 or something like that, and ChatGPT was answering, assuming that he's still 1 year old now. That was so can you teach this to ChatGPT?
I'm glad you asked, because I have a surprise slide. LLMs. So in the summer of 2023, I spent about a week experimenting with precisely ChatGPT, seeing, hey, can we get this to do this for us? Because if so, great, right? Let's work. So these were qualitative experiments. I was just fiddling around, trying prompt after prompt, seeing what popped back. It struggled with formatting. It wouldn't consistently give the JSON of the response we wanted. It would leave out parts. It would give ellipses. Also, ChatGPT generally struggles tons with enumeration, and obviously in trying to detect the periods in a particular sentence, paragraph, whatever, we want the full set of it. Did a terrible job at that. It would generally detect some, but even those it did detect, no consistency in the sort of time intervals it extracted. Sometimes it would have the start of the time interval coming after the end of it, great semantics. And we would have nice false positives like circa 16%, that's the year 2016, right? So we decided, no, we'll stick with our current approach and continue the DSL and whatever. Thank you.